horizon, but some of us can see it. We can see a world where automobile accidents are a thing of the past, because cars can think for themselves. We can see a world without climate change, a world powered by the sun and the wind and the waves. We can see a world where doctors predict disease before it occurs, using virtual models of the human body. We can see a world connected as one community, thanks to communication networks accessible to all. At ansys, we can see exactly what the future brings. Or rather, what we bring to the future. Through the power of simulation, we are enabling innovators to create this new world for everyone. Only then can we engineer what's ahead.
A little more than a century ago, Henry Ford said no to the past. In doing so, he pioneered an entire industry and changed the future. Today, the automobile industry is once again headed into uncharted territory. And wherever this new road takes us, one thing is certain: engineering simulation will lead the way. Simulation is the only way to innovate these groundbreaking disruptive technologies, the only way to engineer advances that have no precedent. In this once-in-a-lifetime industry disruption, simulation breaks through the barriers of innovation, providing deep insights into the underlying physics of these complex machines with unparalleled speed and accuracy. Engineering simulation is truly the only way to validate the performance and safety of autonomous vehicles, to consider millions of driving scenarios, billions of possible traffic and weather conditions, the only way to put a driverless vehicle on a public street. For close to 50 years, ansys has helped automakers innovate with confidence. Now, it's only ansys that offers a holistic solution for engineering the entire vehicle, across disciplines, between physics, tying together every system and subsystem of products, allowing you to get the latest model to market first. And in this disruptive environment, that's everything. The transportation industry is once again poised to change our world. But before new energy sources can power our vehicles, before the autonomous age takes hold, before every safety issue is overcome, there is ansys.
Hello, good afternoon, everyone. This is Mary from Cybernet, and it's really great to meet you here. Welcome to Cybernet Solution webinar about empowering your innovation for electric and autonomous vehicle. And this webinar will focus on the best solutions from ansys, the world's leading CAE software provider, including common battery thermal problems, structural performance, electromagnetic field, functional safety, and automotive optics and virtual reality. Before the event, I'd like to briefly introduce about Cybernet. Okay. Our company is Cybernet Systems Malaysia, and we are a subsidiary of Cybernet Systems from Japan. As a leading CAE company, Cybernet Systems has been providing software, educational services, technical support, and consulting to R&D and design-related departments of manufacturing companies. Cybernet systems provides all sorts of solutions that can fit most of the customers' needs in high-tech. Okay. Cybernet systems provide Cybernet systems provides all sorts of solutions that can fit most of the customers' need in high-tech sectors, including AR/VR, big data, IoT, digital twin, and AR service, IT solution, and engineering services. Our corporate vision is bringing sustainability and surprises to society through technology and ideas. Our goal is to solve the problems of our customers who face increasingly diverse and complex technological issues every day with the technology and ideas that exceed their expectations and to lead you to the next level of innovation. After this event, I hope that you can gain a lot of more insight into the CA solutions that ansys provides. And if you are aiming to be the innovator in the industry, Cybernet is always your first contact to help you succeed. Here, please notice that you may adjust your audio connection through the control panel. Find the audio connection button and change your settings. If the connection is not good enough, you can also try to download WebEx meeting app from your cell phone to join this event. Your microphone will be muted during the whole event. Should you have any questions, please feel free to type in your questions in the Q&A panel shown in here. Okay, I'll be very happy to help. If your question is about webinar content, there will be Q&A session in the end of the webinar. A questionnaire link will be shown to you in the end of the webinar. After finishing the questionnaire, a download link for the presentation files will be provided to you as well. Okay, so now let's move on to the first topic. Stop sharing. Okay. Yes, Papa, please kindly share your screen. So now, our first topic is the ansys overview for automotive solutions. Dr. Kumar Salui from ansys will talk about how ansys solutions can help to innovate in automotive design. Okay. Okay, Papa, can you say something? I cannot hear you now. Papa, you're mute. Please unmute. Just a moment. Participant. Papa, can you say it again? Papa, can I hear you now? Hi, please wait for a minute. I think we are having some voice problem. Sorry, so Baba, I cannot hear you. No, I cannot hear you. Hello. Oh, sorry. That's okay. Yeah. Sorry. Dr. Kwan. Dr. Kwan. Yeah. Sorry. I'm sorry, everyone. I think the Dr. Kamal Salui is having some uh, technical problems. So I'd like to welcome the Dr. Kwang from Ho Chi Minh City University of Technology to make the presentation first. And then in this presentation, Dr. Kwang is going to give an overview of using ansys CFD to assist in the design of battery thermal management system from early designs using airflow, then to liquid, and then recent developments such as refrigerants, mixes, and more. Okay, so Dr. Kwang, can you kindly share your screen?
Did you see my screen? Yeah.
Yes, I can see your screen and I can hear you well.
Okay.
Thank you. Yeah,
So,
thank you.
I start out, right? Hello, everyone. My name is Đặng Lê Quang, and I'm from University of Technology, Ho Chi Minh City. I have a brief introduction about myself. So I have PhD in CFD for Energy Technology from Politecnico di Milano, Milan, Italy. And after my PhD, I worked many years on project involving to cooling systems on electronic equipment, safety systems for nuclear power plants. Today, I'm very happy to stay here and present about safety uses for vehicle battery, electric vehicle battery management systems development. And first, I come here with also my group. That is Phạm Nguyễn Phi Long and Hậu Phước Đại. They are my students. And for today's presentation, I will separate my presentation to two topics. The first, I will introduce about BTMS, battery thermal management system, and the second, I will present about how to use CFD for developing BTMS. First, we say a little bit about BTMS. As you know that nowadays, these days, electric vehicles are the most promising solution for friendly environment vehicles. You see Tesla, also some other manufacturers have the electric vehicles. And the heart of EVs is the power batteries, which will help for fast charging, efficient driving, etc. And when the vehicle is in operation, so temperature will increase, right? And temperature will affect to the battery performance. For example, they will make the loss of energy, cycle life reduce, and some research show that working temperature limits it should not exceed 50 Celsius degree, and the difference between the minimum temperature and maximum temperature should around 5 Celsius degree. So as you see, temperature has a major impact on cycle life and energy capacity of the battery. That's why in the EVs, we must have a system which will help to manage the temperature of the vehicle. So we call that is the turbo management system, and this system will attach directly to the battery always to help to reduce the temperature, to distribution of the temperature on the battery. So we say a little bit about CFD and BTMS. Maybe you will know that nowadays many companies, many industries use CFD because it's the first it improved performance. The results very correct. We can take a look inside of the results, and the cost much less than experiments. And one of solution I always use is ansys, and especially ansys fluent. I'm a kind of expert of ansys fluent with around 10 years working with ansys fluent. And for the BTMS, before I say about how to use CFD to develop BTMS, we should first classify the BTMS. And actually, there are many ways to classify the BTMS, but I classify by the heat transfer medium. We will say that the medium is air cooled, so using air, so we use air cooled BTMS. Using liquid, we can use liquid cooled BTMS, and the other case phase change material PCM cooled BTMS. Many companies now are using air and liquid cooled BTMS. PCM is still under research. This means that you can find many research papers about PCM, but in industry, the usage is still be limited. So today we only say about air and liquid cooled BTMS. First, we talk a little bit about air cooled BTMS. So with air cooling, you will use the cooling system of electronic equipment. It means that we also have natural force convection, and to show how to use CFD for this BTMS. So I will say more about the modified airflow channel. For modify with CFD, actually you can do something like pre-design. It means that you don't need really make the products. First, you use CFD to simulate, right? And then you pre-design, you do evaluate first, and then after you have some results and validate, you can see it's good, so you can use that simulation for the real products. And in modified airflow channel, we will have some kind of modified the flow go into the battery. For example, here, the first thing is GUZ type channel. You can see on the picture here. So this is the battery, and you will use airflow go in and go out to cooling the battery here. So with CFD, and actually this results from ansys fluent, you can see many type of channel like U type. You go from here and you go out from here. Z type, he go here, and this is the outlet, inlet here, outlet here. And similar G type, you have two outlet and one inlet. So for the CFD, we can actually see the results first, and then which one is the best, and you can use that. The second type of the modified airflow channel is air distribution pipe. That is, you will use many pipe and input in the middle of the block of the batteries, and inside the pipe you will have some orifice to have for the air can cooling the battery inside here. You see the outlet is the air will go out here and go in here, the orifice. This is some results. So you see, actually CFD help us a lot to design first, and then we can check even the diameter of the orifice, and then have the very correct result. The third type is reverse airflow. In the field of battery, you can arrange for the inlet and outlet. So in the past, we always use one way, it means that in and out. But now we think that, for example, one in and two out. But with the arrangement like this, so it will help or not. And we don't need really make experiment. We just use CFD, and this is some result from this order. So you can see that for the classical type, the temperature maximum is very high, but with the reverse flow, you will have a lower maximum, and the distribution is better. With the liquid cooled PTMS, actually nowadays many manufacturers confirm that actually airflow is not good as the liquid cooled PTMS. So they have many types of liquid cooled PTMS: direct contact with fluid, indirect contact with fluid, and we will focus on the cold plate. Let I explain a little bit about cold plate. Okay. The cold plate, this means that if you have the batteries and you will have to use a plate with many channels, and to input the cold liquid to transfer the heat for the battery. And in the cold plate technology, you will have the parallel channel and serpentine design. For the parallel channel, you will have many channels arranged in parallel on the cold plate, and then perform your heat transfer. With clearly that with simulation, you can do anything you want, because from 2 channels, 3 channels, 4 channels, and also you can assume that the flow direction, for example, the same flow direction, the reverse flow direction, etc. And this is some result I take from the paper, and this is temperature distributions. And with the serpentine design, this is very new techniques, because instead of use many parallel channel, they will use a channel with many shape. For example, the U shape like this. And you see, you just use simulation, very simple to have the full result. And we have a pre-design to know which one is better. Besides that, you can also use CFD for the process of the optimization. For example, in this paper, they have the shape of the channel like this, and then they have some dimension. They say which one is best for which one is the best. For example, the width of each dimension, so they can optimize that, and then use CFD to prove the ideas. So the ansys is also result from ansys fluent, and from all the results you can see that CFD supports a lot in this field, and we also have some conclusion that liquid cooled PTMS is better than air cooled PTMS, and in the future maybe they will develop PCM, and PCM also will use the CFD to support for that development. That is all. Thank you for your attention.
Okay, thank you, Dr. Kwan.
I stop.
Yeah, please stop sharing. And Papa, can you kindly share? Let's have a voice test. Can you talk right now? Hello, Papa. Um, okay, I think he may still have the voice issue. So now I'd like to invite Anas from Cyber Systems Malaysia to give a presentation about the ansys MBU solutions for structural performance of automobile. Okay, so Anas, can you kindly share your screen?
Right.
I can hear you well, and then okay, now I can see your screen now.
Okay. Right.
Okay. Okay, and yeah. Okay.
Okay. Great. You can go.
Okay, and Anas is the NCCFD and Mechanical Application Engineer in Cyber Systems Malaysia. And in the presentation, he's going to talk about the body, chassis, drivetrain, and every even better case about anything about the structural aspect. Okay, so now, Anas, you can move forward and uh, make the presentation. Thanks.
Okay. Thank you very much, Mary. Appreciate that. Okay. Hi there. My name is Anas. I'm from Cybernet Systems Malaysia, and I'm currently based in Kuala Lumpur. So my presentation today is going to be about the structural performance of automobile. So when we talk about the automobile development, in terms of product or design, structural performance is one of the important aspects that need to be focused on. So today, let's go through how we can take advantage of computer simulation in the design and also development of an automobile. Okay, so first, a little bit of introduction about automotive industry and also structural simulation. Then we will go through how structural simulation can be used in the automotive development. Okay, so the automotive industry has been one of the strongest and also most well-developed industry compared to the others. Over time, as the growth of an automobile ownership increase, requirement for an automobile to be more safe, more economical, or even more affordable are also increasing. So in the automotive industry, actually structural simulation has been widely used in the design and also the analysis of the automotive parts. It is because structural simulation actually provide a very strong support for the design and analysis for components, automotive components such as the suspension systems or the chassis or the wheels and also other kind of automobile parts. So why do we need to do structural simulation? So structural simulation actually helps engineers to understand the structural performance of their design. So that includes something like the stress strain of the design, which subsequently allow us to evaluate the safety factor of the design. It also include the deformation of the design, the vibration response, the overall design weight, and so on. So a few examples of the analysis that are most commonly done include the composite analysis or thermal analysis, impact analysis, optimization, so on and so forth. So there are many kind of analysis that falls under the structural simulation. So ultimately, with the structural simulation, you can reduce the cost and also time of your product development without having the need to build a large number of physical prototypes. So instead of build a physical prototypes, what you can do instead is that you can simulate everything in the computer first, and then later on, you can decide which design is the best, and then you can proceed with building the physical prototypes. Plus, with the ever-increasing requirement for a safer and also more economical automotive product, structural simulation actually can also help in meeting this kind of requirement as well. So the adoption of structural simulation in automobile development can be seen in several parts and also components of a vehicle. So here are some of the automotive parts that can adopt structural simulation into its development. So we are talking about components such as the chassis and also the body of an automobile, where we would like to analyze something like the structural integrity or the safety performance of the chassis. And then we have the drivetrain, which include parts such as the drive shafts or differential or maybe transmission, where where the dynamics and also durability of the parts is crucial. Then we have the wheels, where we may want to further optimize the design in terms of the material use and also maybe the shape of the wheels. Next, we have the suspension, where we would like to analyze something like the kinematics and also compliance of the suspension, or maybe we would like to know the structural durability of the suspension components and so on. Then the automotive interior as well can actually take advantage of structural simulation, where we can evaluate something like the optimized shape or structural integrity of the components, the interior components of the vehicle. So when we talk about the chassis or body of an automobile or vehicle, most common challenge would probably be the overall structural performance of the components. So something like the fatigue life of the chassis, or maybe the torsional stiffness of the chassis, or whether or not the chassis meet the crash standards rating and so on. So those are some of the challenges that engineers might face. So ansys have multiple solutions for this kind of problem. So we can use ansys mechanical, for example, to do static structural analysis, where we can evaluate the stresses or the deformation of the chassis. We can also do fatigue analysis to evaluate the life of the parts and also determine how long before it fails. And then for crash analysis, ansys has the ansys LS-DYNA, which allows for the explicit dynamic analysis. So the user can basically set up the crash test environment inside the ansys LS-DYNA view. So these are just some of the analysis example that you can do with the structural simulation. So one of the example here is the life prediction of the welded joint. So if you are connecting, if the means of connection you are using is a weld, then you can definitely evaluate the life of the weld joint and also include the material properties such as SN curve in your analysis to evaluate such kind of phenomenon. And then another example here is the sag evaluation of a car door, where you would like to evaluate the deformation of the components due to gravity or maybe other kind of loading as well. And then you can also determine the chassis strength when subjected to an impact loading. So something like a roof crush analysis. So drivetrains are another parts or components that can definitely take advantage of structural simulation. So some challenges that designers or engineers might face when designing the drivetrains components include something like the kinematic behavior of a drive shaft, or the durability of a transmission component, or maybe something like the dynamic behavior of the differential and so on. So for dynamics problem, ansys has the multi-body dynamics analysis capabilities, which can help to address these challenges by providing the insight on the interaction between parts and such as gears or shafts or joints and so on. So we can evaluate something like the stresses being developed on each of these components as well during the dynamic operation of the components, or even predict any sort of misalignment on the joints or the connections between the components. So one example that I have here is the multi-body dynamic analysis of a transmission assembly. So this analysis was done to evaluate the synchronization characteristic when DCT gearbox is in shifting, when you try to shift gears. So the simulation was done using one of the ANSYS product called ANSYS Motion, which is a specialized tool for multi-body dynamic simulation. As for the simulation model, all bodies here are connected to one another using appropriate constraint, context definition, and also joints. Then as for the input, the sleeve actually initially rotating at 694 RPM. And then as the result, during the meshing process, we can determine that the gear meshing process took about 0.0683 seconds for the meshing process to take time. And also based on this graph here, we can determine that the gear is synchronized well. Next here we have wheels. So wheels are another part of an automobile that many people might be interested in because wheels actually contribute to the unsprung weight of a vehicle, of a certain vehicle. So the goal is actually to always reduce the weight of the wheels as much as possible. So therefore, some of the challenges when developing a wheel revolves around optimizing the design shapes of the wheel and also the material used to build the wheel in the first place. So, when we talk about wheels, some of the common material that has been used to make a wheel something like a steel or aluminum alloy, while carbon fiber as well may also be seen in some of the more high performance vehicle. In this case, ansys have a solutions called ansys composite preppos, which allow us to design the composites layout definitions and also evaluate the carbon wheels structural performance and also its composite failures. So here an example of composite wheel design and also composite wheel structural analysis. Basically, this analysis was done using ansys composite preppos, or SCP for short. In this case, we created the fabric, the composite fabric using the epoxy carbon woven prepreg with a thickness of 0.4 millimeter. Then the fabric is being used to define the stack-up properties, which then allow us to configure the layout sequence and also fabric orientation. In this case, with the orientation of 0 and 45 degrees of the
drastically wrong, man. I changed the laptop, even that laptop is also not working.
I'm sorry. Okay, so in this case,
what does she say? She has to cover your topic or it's dropped now?
I don't know, like she tried second time.
Papa, I can hear you now.
Is working, but this one, like when I enter in actual this one, I cannot.
Okay, Anas, please go ahead.
Okay, let me continue. Sorry about that. So yeah, in this case, I specify the fiber orientation of 0 and 45 degrees. And then firstly, we can evaluate the strength of the composite layout by analyzing these polar properties of the composite. And then afterwards, we can, evaluate something as we can observe the layered composite thickness and also the orientation across the all surfaces. And then after we finish designing our composites wheels, we can transfer it to the static structural analysis, where then we can evaluate the structural performance of the composite failure. So we can observe something like the region of high stresses, which in this case were found at the hub region and also the leading edge of the spokes region. Okay, so next we move to the suspension. So when it comes to suspension design, aspects such as the kinematics and compliances of the suspension system need to be taken into consideration. So, and then apart from the dynamics of the suspension, the structural performance and also durability of the suspension component, such as the arms and also the knuckles, also need to be evaluated as well. So again, with the multi-body dynamic analysis, we can predict the kinematic behavior of, and also the, kinematic behavior and also the compliances of the suspension systems, like springs under any types of loading conditions. And then of course, you can also perform a structural analysis. So to evaluate the stress being developed on each of your components of your suspension. So here we have an example of a multi-body dynamic analysis of a suspension system. So in this case, actually the ground is subjected to a vertical motion, and then the sway bar is also being subjected to the horizontal motion. And then all of this component of this suspension assembly has been constrained using appropriate contact and also joints. And then as for the results, we can evaluate something like the forces of each of the springs throughout the duration of this simulation, which in this case is 1 second. We can also evaluate something like the gap and also the duration of which the tire is not in contact with the ground. And then of course, we can also evaluate something like the stresses being imposed onto one of our parts, which in this case is the knuckle part of the assembly, which in this case have the maximum equivalent stress of 103 megapascal, around 103 megapascal. Right, so lastly is the interior components of an automobile. So interior parts actually may be subjected to a certain types of loadings, and also require some sort of clever design to maximize the structural performance, and also helps in making material selection process and also subsequently reducing the overall cost of the design. So some challenges may arise when it comes to the interior parts of a vehicle, including something like the thermal expansion of a dashboard, for example, under a constant heat. Or maybe some people might be interested in finding a way to optimize the shape of some of the interior components. So ultimately, this kind of problem can be solved with the help of structural simulation. So with ansys mechanical, for example, you can evaluate the temperature distribution across the entire components of interest. And also you can evaluate the subsequent stresses and also deformation of the components due to the thermal expansion. Okay, so here is an example of topology optimization, which in this case is for the pedal design. So actually we started off with an original design, which is weighing at about 240 grams. And then afterwards, we can do structural analysis to evaluate the original stiffness or deformation of our design. And then afterwards, we can specify our design objective, which is in this case, we would like to maximize the stiffness. And also we can also add some kind of a manufacturing constraint as a boundary condition as well, which essentially allow us to create a more feasible optimized shape. And then after the optimization process was done, the new optimized shapes design can be verified using the same boundary conditions and also loading like the original design. So as for the results, the maximum deformation of the new design is about 0.7 millimeter compared to the original 0.616 millimeter. So although there is a small increase in the max deformation, actually the final mass of the optimized design is 143 grams, which is about 40% less than the original design. Okay, so next I would like to talk about perhaps one of the perhaps the most important component of any when we talk about structural simulation, which is the material data. So the next part is going to be a little overview of the ansys Granta material data for simulation, or ansys Granta MDS for short, which is essentially a detailed and also comprehensive material data library for simulation. So generally, most of the, any vehicle, automobile is made of the metals, plastic, rubbers, and others, something like composites, for example. So according to statistics over time, non-metal material classes have gained more and more popularity in the automotive industry. So this is mainly due to the ever-developing material science and also material technologies, meaning that materials such as polymers and composite have been stronger, lighter, and more durable than metal in some cases. So therefore, nowadays, as an automotive development, when we talk about automotive development, the options of material that engineers can choose from becomes wider and also much more diverse nowadays. So more materials included in the design and also development of a product means that when it comes to simulation, more material data is required. So ansys Granta was developed to actually help users of ansys to maximize their use of this kind of use of their simulation tools. So we found simulation engineers were faced with three challenges when it comes to material data. So the first one here is time searching, assigning, and also formatting material data into simulation. And then the next one is the different material name used, when it comes to departments within the same company. And then the third one here is simply the inaccurate material data, which can subsequently resulting in the poor simulation accuracy. So basically, all of these will lead to a more repetitive simulation workflow, a poorer quality simulations, and also overall lower the engineering productivity. So essentially, the benefits of ansys Granta can be broken into three. So you have the accessibility of the Granta MDS, which is basically embedded in any of the ANSYS simulation tools. So you can find it inside the ANSYS structures or ANSYS electronics or even ANSYS fluids. So it means that engineers have access to the right material in a few clicks. And then secondly here, the material data available in the in the Granta library are actually already in the simulation ready format. Therefore, engineers can save time from having to search and check for material data from a variety of sources, and then subsequently slowing down the simulation processes. And then finally, actually, is the trusted data. So MDS leverages the ANSYS Granta's market-leading materials to bring a trusted data set of over 2,600 materials with a 20+ material properties. So yeah, with 750+ material classes and growing, MDS actually offers a broad coverage of material classes. So that include material classes such as metals or plastics or ceramics or woods or composite glasses, foams, so on and so forth. So there are many material classes being included and also many kind of material properties also made available inside this kind of library. Okay, to summarize everything that I've just presented just now. So basically, the structural simulation has been widely used in mechanical design of automotive parts. It is simply because with structural simulation, we can actually reduce the cost and also time, time of the product development by essentially eliminating the needs to build a very large number of physical prototypes. And also, as seen from some of the example, ANSYS actually provide a very comprehensive structural simulation capabilities for design and analysis of automotive, products, automotive components such as the suspension, chassis, wheels, and so on. And then finally, we can understand that an access to a comprehensive material data library, which in this case come in the way of ANSYS Granta MDS, can actually boost the productivity of simulation engineers. So that's all from me. Thank you very much.
Okay, thank you, Anas.
Yeah.
Okay. So next, I'd like to welcome Dr. Nicholas from Cybernet Systems Taiwan. And then Nicholas is going to talk about ANSYS HFSS and an EMA 3D co-simulation of vehicle circuits and cables in electromagnetics field for automotive electronic application. Okay, Nicholas, can you kindly share your screen? Yes, I can hear you well. Okay. So
Okay,
Nicholas, yeah. Yes, okay. So Nicholas is the ANSYS HFSS application engineer in Cybernet Systems Taiwan. And then this talk will focus on the simulation cases and solution of ANSYS HFSS, ANSYS SI Wave, and ANSYS EMA 3D co-simulation of vehicle circuits and cables in electromagnetic field. Okay. So Nicholas, you can now go ahead for your presentation.
Yes, thank you, Mary. And hello, everyone. My name is Nicholas, and I'm from the Cybernet. Today, I will introduce, as far as you know, the ANSYS HFS and EMA 3D co-simulation of vehicle circuit and cables in electromagnetic field for the automotive electronic applications. And talking about automotive electronics, we all know the 5G communication is developing very soon. So there are many devices will becoming a new requirement for the automotive electronics. And we will considering the design way to reduce our cost over time, maybe we should put in our product in the market very soon. So we need to do some simulation for our automotive electronics designs. So let's go to my slide, and I will show some solution and maybe the platform of tool to introducing to you how about the ansys to design this circuit and the cables in electronic magnetic simulations and to automotive applications. So let's go to automotive system design challenges. And the first is the mobile revolution continues. So we will considering our device is very small and integrations. So we need to using the many way to measurement and testing our device. But you need to more faster and low power device. You should consider more design. Maybe we should need more idea to reduce our size, and the cost will be a key in this design decisions because there are many kind of device they will put in the different way, and then there are many sensor in the car. So if the cost will be hidden in our products, there will be customers will ask us to reduce our cost. So and the other way we will talking about the motor design. The motor design considering the more efficiency and the performance for the EV cars. So due to the 5G and EV car development, the motor design will be a key to these industries. And the next is a new requirement, and the new requirement will be maybe some power efficiencies and wireless and ADAS systems. The ADAS systems will be a self-driving key rule of the all systems. And if you want to build a level 2, even a level 3, you should put in the many sensor in a car. So we will considering the ADAS system design will be not follow the method of the trial and error, because there will be old method, and there will be that your design time, it will be long time to design your products. So we will considering about the simulation to do the ADAS systems, and the analysis of the antenna performance into the radar is the basically way to the ADAS. And the advantage of the systems designs is the all systems considering, and maybe you will put in the ADAS and radar in the environment to measurement, and maybe the simulation will doing this thing in at the same time. They will reduce your testing time. And the next is the EMI and RFI effect. And talking about the new challenge of the automotive, the EMI will be certifications in the our products. So we will considering the reliability, maybe some systems, but not the most important thing is the EMI, because the certification is print layer. So you should doing the certification, there will be your product to the market. So we were considering about the simulation is very important thing in the automotive system designs. So let's go to why we need to electronic simulations. The electronic simulations will be advantages of simulation to do the help you to do the testing and the measurement. They are very reduce your cost, because of the simulation will not replace the measurement, there will be help your measurement is more efficiency. So thinking about the simulations, we will put in the same environment with the measurement and reduce the testing time, and you will be very efficiency to do the your product designs. Now, we need to introducing some simulation platform to you, and there will be a EBU tool, electronics tool to you, and the ansys will providing many well platform that is called the ansys electronics desktop. The electronic desktop is the electronics magnetic studio, and the single unified desktop for electronics tools. They will combine the HFS and Q3D, even the circuit together, and I speak they will set in the same interface, even the Maxwell's. So if their interface is similarly, you will learning did those two very fast, and the design will be in the same platform, so you can doing multi-physics simulation for your products, and this is a powerful platform to you, and you were using those tools to do the design from the antenna, for the motor, and for the cooling, and for the some sensor of the systems. Even the system level simulations, you will be using the simpler and to do some simulation, like they are called the team builders now, and those kind of simulation will help you and to do the system level simulations. Let's look at simple example for the electronic magnetic analysis. We're using the motor case to do some case some simulation for you. First, you will follow the motor case and to explore the motor model in 2D, and you were using Maxwell to simulation the 3D and magnetic FEA analysis. And if you finish that, we will put in the ansys simpler or twin builder to do the power electronic circuit system simulations, and there will be a system level simulation in this platform. And if we want to also get the thermal analysis, we were using ice-bake. Those kind of tools were in the same platform they call ADTs. And if you need to RCG, extract the RCG, we were using the Q3D, and you will extract the S parameters, and we were using the SI wave and HFSS. Those kind of simulation, we will be in the same platform they call ADTs. But sometimes we need we will make some structural problem. They were using the mechanicals, and something we're using the CFD. So we have the ansys workbench, and there are good connection for the ansys structures and ansys CFDs. So a motor design flow will be created by by those tools. We may design our motor in this platform, and you will get the many results and many physical issues, and they will be reduce our design time, and they will help you go to market very soon. So again, start with the design analysis and dynamic response and the radiations and the sound analysis. There will be a simply way to do the MVH versions. So we will, if there is more motor problem or issues, you please feel free to contact with us. We will providing the very complete platform and solution to use. If we finish the motor problems, we will go through in the ADAS problems. The radar will be ADAS key point of the designs. First, you will using the different server in the radar systems, and the radar sensor design and analysis will be many one to consider in the designs, and the radon will be a key way to do the radars, because the radon will be a factor of the antenna performance. First, we will design our antenna and our array in the HFS. Second, we will put in the antenna to the radon. The radon will be analyzed by the HFS very soon, very efficiencies. But now, if we finish this kind of antennas, we will be spend many time, and there were a high time cost of the simulations. There are many people ask us to reduce the simulation time, so we will help you to develop your HFS platform, and you using this kind of tool very well. We will introduce the HFS server and help you to fast your different way issues. Like the antenna, we will introduce the FEM servers, and antenna and radon, we will using the hybrid regions, and the antenna and the actual radon, we will introduce in the shooting function rate solution to use. There are different server will reduce the simulation times. But in the new version of HFS, the HFS will combine with the shooting function rate. The shooting function rate will simulation the dielectric material well, and in the old version, the shooting function rate just only can simulation the metal material. And now we will introduce the new shooting function rate simulations. First, we will compare these two results of the HFS and the shooting function rates. The HFS will simulation the radar very well, but you will be a high cost over the simulations you using the 32 core and the 300 more than 300 gigabytes RAM. And you will spend 4 hours to do the simulation. But in the same case, when using the shooting function rate, they will be joined to a GPU, and you just only 2 minutes, and you can get the same result of the same case. So the shooting function rate is more efficiency in the radon simulations. Now, there we are solved two issues of the electronics. There will be 3 points we will focus today. First is motor, and second is ADAS systems. Now, finally, we want to go to the EMC. The EMC issues will be halfway to simulations, because the test and measurement technique is very long time for the developments. So maybe we will using the simulation. Now, there are some EMC tests and some chamber, and will make it up in the this kind of simulations. And the most important thing is we will a new method to do the EMC simulations. That will be EMS 3D. The EMS 3D will be you can work thinking like they will simulation the electrical electronics, and they will modeling your cables. And we were thinking about the EMC problem will be the middle line. The cable is if the cable is straight, so we will be make up the EMC problems. But in the cable will be a meter lines. The different way to the cable will be some radiations in the corners. So we will considering about the cable radiations in the all systems. But in the cable modeling of the HFS, there will be some big cost of a simulation because you need more measures and more simulation time to modeling your cable. So we were introducing the new tool of the ansys is the ansys EMS3D cables. The EMS3D cable will be totally a cable tool for the ansys, and there will be just put in the KPL file for the EMS3D. They were building the old cable in the interface, and you will simulation those cable in these tools. So now we will using the cable simulations and the total car models, and you will simulation some cable problem in your device. Now we will put in the cable and simulation the EMC problem. Even the EMI level of the antennas we can use in EMS3D to simulation very well. You can get many result like the antenna in the low frequency efficient the interference. So we will doing this kind of antenna to put in the EMS3D to do some simulations, but you will interested in the what is the difference in the HFS and the EMS3D cables. Those two will be a full wave simulation for the electromagnetic fields. So first is the HFS model in the left hand side, in the right hand side, and the EMS3D model in the left hand side. They are same way to do some magnetic lossy materials in the models, and there will be a lump pole sitting in the HFS and the same pole sitting in the EMS3Ds. Now we're looking at the EMS3D cable performance and the HFS. There are good agreement of each others, and there will be nothing to carry about the EMS3D. There are great accuracy and more efficiencies to do the same simulation with the HFSS because the model of the cable will be complex, and there are some isolations, and something will be hard way to do some modeling in HFS. So we were using the EMS3D to do the cable simulations, and you can put in the EMS3D simulation result with HFS integrations because the EMS3D will explore all cable simulations and characteristic to the HFS. HFS will follow this cable characteristic to do the simulation in the PCB. Like the IBIS model will bring together, so you will get the accuracy model in this kind of simulations. And even you can put in the HFS near field result to the EMS3D. The EMS3D will analyze the electromagnetic field in the same environment by the HFS near field results. So there will be a co-simulation between the EMS3D and HFS. So there will be simulation results, and the EMS3D output the cable characteristic, and the cable performance will interface of the interference of our package and our IC. So in the TVS diode will be put in this PCB, and this kind of simulation will be help us to do some PCB simulations more and more efficiency, and will combine with the cable interference. So I think I finished my presentation. Thank you, everyone.
And now, although we are a little bit delayed, we still have 5 minutes of break, and we'll come back after 5 minutes. Thank you.